I'm Lou Wallach, Director of Flight Test. Many people imagine flight testing as being helmet and goggles and white scarves and old biplanes like this beautiful old Boeing P-12. However, today, the technology of flight test is modern, just as the airplanes behind me, the 757 and 67. It's a rigorous engineering discipline that assures the Boeing airplanes that are delivered to the airlines are the world's best tested, best developed airplanes, and are the best for the airlines and the customers to fly. I'd like to have you join us now to see how we now test airplanes.
Actually, flight testing begins here in our wind tunnels, where hundreds of basic designs are tested before one is chosen. The 757 and 767 flew a total of about 30,000 hours in our tunnels, proving their efficiency before the designs were finalized. Engineering test pilots were involved early on too, working with the designers to create what is, on the 757 and 767, the world's most advanced flight deck. They've stayed involved, providing the experienced pilot's perspective as the new flight deck took shape. The pilots also have been a main link with airline pilots, making sure their experience is reflected in the flight deck design. And while the pilots have been working closely with the flight deck designers, flight test engineers have been helping the 757 and 767 engineering staffs develop a test program that will gather all the data needed to win Federal Aviation Administration certification. Since many of the sensors to gather that data are most easily installed during manufacturing, this early coordination pays off in an efficient and economical test program. Finally, 3 years after program go-ahead, the new bird is ready for the first flight. In command are the flight test pilots that have followed her progress so closely. Also aboard is basic test instrumentation that begins the long process of sensing, measuring, and analyzing her every move. But this is the moment of truth. Perhaps the most dramatic and exciting moment in a pilot's life. The first flight in a brand new airplane. Less than 6 months later, another carefully instrumented new airplane lifts off for the first time. In a few tense moments, we prove again that all the individual components will work together in the air. These initial flights kicked off a flight test program that involved 4 767s and 5 757s. Altogether, more than 2,500 flight hours went into testing, refining, proving that these airplanes were ready for certification and airline service. This successful program, the first time any manufacturer has simultaneously tested 2 brand new airplanes, is the result of more than 20 years' experience building and certifying commercial jets. Beginning with the 707, seen here taking off in a 50-knot crosswind, Boeing has been developing test procedures and techniques so that today we can conduct similar tests more quickly and gather more information as well. Experience has helped, of course. We're smarter now. We know more about what tests are needed and how to best conduct them. But technological changes have helped as well. Modern computer technology, for example, allows us to collect as many as 10 billion bits of information during a typical 2-hour flight. And because computers are getting smaller, we're now able to collect, store, and examine this information on board the test airplanes. So now we can immediately check the data, and if something's wrong, redo the test. This ability to make real-time spot checks has saved many hours during 757 and 767 testing. But these improvements didn't come cheaply. The onboard and ground computer systems now in use cost some $25 million just to design, not counting hardware and day-to-day operating costs. Their benefits are speed and accuracy. Now, much more comprehensive test results are available for analysis in hours instead of days. So the program moves more quickly. Fewer airplane modifications are necessary, and overall costs are reduced. For example, it took a total of 40 airplane months. An airplane month is one airplane committed to the test program for 1 month to certify the 747. This is one of those trials, a VMU, or minimum unstick speed test, that demonstrates the slowest speed at which the airplane will take off at an extreme pitch angle. By the way, the smoke and flames are from a wooden block under the tail, not from the plane itself. But the 757 and 767 programs combined took only 65 airplane months, cutting 15 months from the 747 pace. Most of the testing involves routine flying and establishes the basic performance characteristics of the airframe, engines, and flight management system. But some of the tests aren't routine at all, and those are the ones that come to mind when flight test is mentioned. This looks simple enough, doesn't it? But notice the red tab at the tip of the wing? That little device induces flutter, or a wave-like motion in the wing that could, if the design is wrong, shake the whole plane apart. These flutter tests prove that the design is self-damping. That is, it naturally cancels these waves. Seems innocuous from the outside, but in fact is so risky that only the flight crew is allowed on board for these tests. Another set of tests checks the airplane's performance at very low speeds, finding the precise stall speed under various conditions. Tests like these establish both the airplane's handling characteristics and the basic handbook data airline pilots will use. These tests also involve a deliberate over-rotation on takeoff. Here the pilot forces a 747's nose unnaturally high to see how it'll behave. As predicted, the 747 handles the mistreatment easily, quickly nosing over and regaining speed at the pilot's command. To check ground handling, we run splash tests to show that water or slush from wet runways won't fly up into engines or inlets on the airplane. Another visually dramatic ground test simulates the conditions found when a pilot must interrupt a takeoff. These refuse takeoff, or RTO tests, put maximum stress on the tires, wheels, and brakes of the airplane, as you can see in this test of the 747 flying command post. Such tests let us know when to beef up the gear so it can withstand the punishment. Here again, technology has improved. The 757 and 767 ran through the same tests quickly, if less dramatically, because we knew better how to predict the stresses, and so could install wheels and brakes that would absorb the punishment more readily. A comparable set of landing tests determines landing distances. In the past, the airplane was literally flown onto the runway with little of the normal landing flare. A recent change in testing procedure, however, has led to a less dramatic approach to gather the same information. But testing isn't limited to new models. Each modification in the airplane or its operation must be proven airworthy and certified. we're demonstrating the 737's ability to operate from unimproved fields, a real plus for some of our customers. We also studied high flotation landing gear for the 707, gear that would adapt it to unimproved fields. And we looked at a 727 with added rocket motors for improved takeoff performance from high, hot airfields. Not all these changes are incorporated in our airplanes, but they do help us keep right at the leading edge of jet transport technology. We also participate in other tests of interest to the air travel industry. Here we're running a set of exercises to understand the wake vortex of wide-body airplanes. That vortex determines the separation needed between the big planes and the smaller craft following them in for landing. Whew, even the pilot got excited about that one. Then there are the problems that sometimes occur in any test program. You'll note that the right wheels on the 737 seem just a bit wobbly. They are. A part had failed, providing one of those incidents that liven up a test pilot's day. While some airplanes are put through their paces in the air, others never leave the ground. In its fatigue test, this 767 is put through the stress it would meet in a normal flight once every 4 minutes. In a year, it will have gone through more than an airline lifetime, or about 20 years of service. This is beyond certification requirements, but it helps confirm our confidence in the durability of Boeing airplanes. The other major ground test is the static test. Here, the 757's wing is stressed to the breaking point to prove its ultimate load-bearing potential. Again, this exceeds certification requirements. Boeing alone in the industry tests to destruction, but it provides a firm basis for future airplane developments.
I began this film by drawing a distinction between the old silk scarf days and today's rigorous engineering test pilots, and between the seat of the pants testing of the old days and the computerized testing of today. Some people may think that the old days were more fun and more exciting because there was more risk. The challenge today is to make airplanes more useful for the airlines and more comfortable for the passengers. We at Boeing like this challenge. The thrill of flying and testing these sophisticated, complicated, useful airplanes is more fun and more thrilling than the old birds that we used to fly years ago.
Flight of the 747 took place on February 9, 1969. From that moment, Boeing flight test personnel had their work cut out for them. The decision had been made. All tests required for Federal Aviation Administration certification must be completed before the end of 1969. they had to carry out approximately 1,500 hours of in-flight testing that would take the 747 to the outer limits of performance, well beyond what would be required to meet all Boeing and customer requirements, as well as FAA requirements. It was a big task. It required using the first 5 airplanes built to get the job done on time. Each of the flight test aircraft had its own select crew, and in general, each aircraft had its own special assignments. Number 3, with its special nose boom, would measure air gusts during in-flight maneuvering while flying through turbulence and on landing. Number 2 concentrated on landing. Number 1 on stalls and system testing. There was plenty of work for all 5 aircraft. The planning for that work all began when the 747 was just a paper airplane and the engineers began making the first of many performance predictions. Wind tunnel testing resulted in predictions about drag or wind resistance and resultant range and fuel consumption. Fatigue testing made it possible for engineers to predict structure lifespan. Static testing established outer limits, just how much the aircraft could withstand before being destroyed. This test, the wing was flexed 26 feet from normal position and still did not break. Predictions had been made. Now they would be put to the test. Many tests were conducted at remote bases. Number 1 aircraft tested takeoff requirements and capabilities at Edwards Air Base in California. Edwards has the longest runway in the United States. Weather conditions at Edwards are very good, too. Tests here included taking off with the aircraft 3,000 pounds above the maximum takeoff weight, and then cutting the fuel supply to one of the engines, making it inoperative. This not only showed the aircraft would perform as predicted, but also that procedures to be used in such an unusual situation were satisfactory. Another test performed at Edwards turned out more spectacularly than intended. The test, a refused takeoff, called for bringing the 747 up to its takeoff speed, at which point all the brakes would be applied to bring the aircraft to a complete stop. Without use of the engine's thrust reversers, the aircraft was brought to a stop in the required distance. But the unexpected happened. A malfunction in the anti-skid system resulted in excessive stress, causing one of the tires to blow out and catch fire. In order to comply with FAA test regulations, none of the standby emergency vehicles were permitted to come to the aircraft's aid for 5 minutes. That's judged to be adequate time for emergency vehicles to reach an endangered aircraft. Finally, time was up, and the burning tire was quickly extinguished. Detailed examination showed no structural damage. The test wasn't planned that way, but it was reassuring proof that the landing gear had indeed been designed for safety. To a large extent, the success in meeting the test schedule was the result of the ground crew's attitude. The men treated the aircraft as if they owned them. The result was a feeling of friendly competition to see which airplane could outdo the other. Each team was anxious to prove themselves and their airplane by taking on certain tasks. Number 2 airplane was sent to New Mexico for landing performance tests, refused takeoffs, and autopilot work. The reception was impressive. It seemed the whole town of Roswell turned out to greet the crew. The friendly attitude made it easier to put up with the long hours of work that were in store. The braking system was given a severe workout. All 747s are equipped with an anti-skid system. When brakes are applied, the wheels don't lock. There is no skidding. Tests are conducted with the system in operation and with it in various failure conditions. 2 wheels disconnected from the anti-skid, all wheels disconnected, and so forth, to show the performance of the aircraft under varying conditions. Frequent visual checks are made of wheels, landing gear, and underside of the aircraft. It's hard on brakes. Approximately 200 of them were used, but it does prove the safety of the aircraft, even when pushed well beyond normal operating limits. While number 2 was in Roswell, number 3 was conducting hard landings at Seattle. Tests proved that the landing gear is very forgiving. Even these hard landings felt soft and presented no control problems. Performance of the aircraft could only be judged in relation to environment. It was essential, for example, to have accurate measurements of weather conditions at the time of each test. A 10-mile-an-hour wind can make a big difference during landing. Flight manuals dictate the proper landing procedures and are very conservative. The stall speed is established, and then the plane is always operated 30% above that established stall speed. There is always that extra built-in margin of safety. The speed at which the 747 will stall and its reaction was established in approximately 500 tests conducted at various altitudes. The 747's excellent flying characteristics are evident. Stalls are gentle and fully controllable. The 747's inherently good flying qualities were also evident during flutter testing. A chase plane was used to help observe vibration or flutter induced by special red veins attached to the wings. The aircraft was pushed to limits well beyond any that would be encountered in normal flight. But the 747 reacted as predicted, and the structures proved to be self-dampening. The flutter or vibration did not amplify or grow. Recording devices were located throughout the aircraft and all control surfaces to radio information to monitoring ground stations. Engineers on the ground observed and confirmed results of the tests and gave instructions or clearance to proceed to the next test situation. During tests, the aircraft reached a speed of Mach 0.991, or just 5 miles less than the speed of sound. At all speeds, the 747 proved to be highly stable. As often as possible, testing was done concurrently. It was frequently possible to conduct certain systems tests, hydraulic, air conditioning, electrical, and so forth, at the same time as, say, drag or level flight performance tests. This was one of the techniques that made it possible to complete flight testing in such a short time. The 747's capability was evident during the spectacular VMU test, which determines maximum takeoff performance. In this test, the tail section of the aircraft is purposely put in contact with the runway. A hardwood skid protects the tail section. The speed at which liftoff occurs is called the minimum unstick speed, or VMU. This demonstrates the 747's ability to withstand inadvertent abuse, as well as determining the aircraft's ultimate takeoff performance. The most important time saver in the test schedule was the simultaneous use of 5 aircraft. Many different tests were conducted at the same time in many different locations. Taxi tests to prove visibility and ease of handling on the ground. Spray tests at various speeds to check against water being ingested by engines or air conditioning. Testing the autopilot in various failure modes to prove that the pilot can always recognize any abnormal situation and control it. Landings in 35 to 40 knot crosswinds. Hard landings with initial impact on the left or right gear. Shimmy testing nose gear linkage by machine grinding parts to simulate excessive wear and testing the results. Every test pushed the 747 to limits it would never encounter in normal use. Massive amounts of data from these tests were then fed into computers, the real key to how such a complicated testing program was completed in such a short time. Analysis of all the data compiled would have required approximately 10 years without the use of computers. Ten months after the start of flight tests, the results are in. The 747 is all and more than the designers and engineers had said it would be. It has proved its capabilities to the satisfaction of everyone involved, including the people who issue the official certification of airworthiness, the Federal Aviation Administration, as expressed in this statement by Arvind Basnight, Director of FAA Western Region.
As a result of this effort, which included some 1,500 hours of test flying, we are convinced this airplane meets or exceeds the standards for safety evolved in civil aviation history. We therefore recommend the Boeing 747 receive the FAA type certificate.